Hello, and welcome to another edition of Don't Plug In That Old Radio. Today on the bench, we're featuring a pair of EMMERSON 505s AC/DC battery sets. We've got two of them sitting here. This one's rather manky. The leather handle is in really rough shape, and it's just downright filthy. This one's in very nice condition. In fact, it's in much nicer condition than it looked in the photographs on eBay. The reason I bought the second one over here is because it doesn't have any dents in the front. And when I purchased this one, I noticed you could see there's an indentation in the front panel right here. Now, I may be able to get that out, but hedging my bets, I went ahead and bought the second one because it was cheap. It was fairly, actually they were both very inexpensive. They were $30 a piece, which is pretty reasonable for eBay. I think it was $14 shipping as well. That was very, very reasonable. This one is the one that was featured in the video where we talked about, in Nerd's Corner, where we talked about having the heater string. Let me come back here. The heater string is powered by the cathode bias on the 117N7 audio output, which is also the rectifier. It's a two-part tube. And the seller told me that, you know, there was a lot of pictures of that set, and he was very clear in his description that the 117N7 was missing. All the other tubes were there. As you can see, it's in really nice shape. There's a little wear on the leather handle. There is a scuff mark up here on the top corner, but other than a little bit of cleaning, I'm probably going to leave this as is, as a survivor. It's got the back, which is nice, and it's in good shape. It isn't all broken up. It's got all of the original papers on the inside, including a sales and service from Spokane, Washington. It has the correct cord with the little wing on it, and that's designed to plug in here when it's on battery operation. If you remember from the video, one of these has to be grounded so that the battery minuses get grounded, so it has to go in that direction to run on battery. If you try to put it in the wrong way, that will prevent it. So it's the original cord, and it's kind of dry, and that's a shame. I was hoping I could keep it, but maybe I can transfer this little attachment to another plug. It's a shame I can't salvage this cord. It's got all the battery connections. I've had this out of the cabinet. The chassis is clean. The speaker's intact. This radio had a very good life. It's in very nice condition. This one, on the other hand, is manky top to bottom. But the real problem is the guy that sold this, P Morse 485, P Morse 584, P Morse 584. Avoid this guy like the plague. This is a newer set. This is the 1947 model 12 and 20. It's still got the external antenna, but they've shifted over to a 35W4 and a 50B5, still using the same scheme to power the tube string. And then there's a version that came out after that in 1948, which is essentially the same, using the same tubes, but they've dropped the external antenna attachment for some reason. But anyway, this guy sent me there was one picture of the front and one picture of the back. And you can see that's the picture here that's up on the screen right now. And the only thing he said was for parts not working. Now, I wasn't expecting a lot, but when I took the thing out of the cabinet, I have tubes in it now because I rounded them up here, but he had ripped or stripped all of the tubes out of here. And when I got this thing, it was absolutely filthy, but where every tube was, the sockets were spotless. You could see the tubes had just been pulled out. but made no mention of it in the text. He said, for parts not working. I've sold a lot of stuff on eBay. You know, you just tell people there's no tubes. I probably would have bought it anyway for parts, just in case. But to take the picture from an angle where you can't see inside and then make no mention of the fact that the tubes are stripped out, that's just being a real scumbag as far as I'm concerned. I didn't pay a lot for it, so I'm not sending it back. But just be advised, this guy he's not truthful in his advertising. I know I'll never buy anything from him again. And but at any rate, this is a different chassis than the one we're working on. Fortunately, this one is in beautiful condition. The other one here, even underneath, it's really torn up. All of the battery cables are missing. And somebody's worked on this over the years and just done crappy work. I mean, there's just... Somebody's replaced a cap here, and I think this one, yeah, these have been replaced, but whoever did it did a really crappy job. It's not recent work. This I will probably go ahead and get running because I've got all the tubes to do it. And then I'll just sell it off. Probably won't have the tubes in it, but I'll let the guy know, whoever buys it, that it does work if it has tubes. But I will keep the tubes in my stash because there's $75 worth of tubes in there now that I would rather have in my stash. But I will see if I can get this one working just for the heck of it, but I probably won't do a video on that one. Where was I going with this? Oh, I remember now. My memory is excellent. It's just very short. If you buy one of these 505s, any of the versions, whether it's this one, chassis model, this number from 46, or the ones from 47 or 48, if you're not planning on running it on battery, don't worry about the 3Q4. You don't need it. The audio output is handled from this tube when it's running on AC. You've got your RF amp, your oscillator converter, IF amplifier, first detector, or detector first audio, and then it either uses one or the other tubes. On AC, it's going to use the 117N7 for the audio output. But if you're running it on battery, it uses the 3Q4. But when you're running on AC, this isn't even in circuit. It's not, as far as the radio knows, it doesn't exist. So you'd only need the first 4 tubes and the 117N7. Or in the case of the 1947 or 48 version, you'd need the 35W4, the 50B5, and the 4 tubes in the front end. And again, you don't need the 3Q4. It's just not needed when it's on AC. No harm putting it in, but it won't function. It won't do anything. We have the little thing out of the cabinet. As you can see, all the tube shields are in place. The chassis is almost spotless. It's extremely clean. Very impressed with the condition of this thing. Somebody has worked on it at some point in time because there's a new filter capacitor in here, but that looks like it was done probably in the 60s, would be my guess. But everything else under here is just beautiful. It's nice and clean. It's neat. You can tell nobody's been monkeying around with it. And again, I don't care that the other one has been worked on. It's just that the guy pulled the tubes out. And I knew what he'd say, but I called him on it. I said, that was a pretty scummy move to pull all the tubes out before you shipped it. And I knew he was going to say, they weren't there. And sure enough, he comes back, they weren't there when I got it. Great. You put it in the description. That's my whole point, though. You put it in the description. You just tell people what they're getting. You don't try to pass something off. Anyway, The speaker's in great shape, no rips, no tears, and before I do a buzz 1151, just kidding, Buzz. Love your stuff, man. I'm going to put a cover over the speaker. And that poor guy manages so often to stick a finger in a speaker, and I feel bad for him every time he does it. So we're going to put that over there to keep the cone protected so I don't get stupid. Because it wouldn't be the first time for me either. Let me find some tie wraps. Okay, the speaker's protected from my big fat fingers. I just can't get over how nice and clean this set is inside. It is just spectacular for the age. There's a little bit of dirt here on the dial face that'll come off. There's a couple of very small scratches over here. In fact, I bet I can buff most of that out of the paint. It's mostly dirt, I think, in the scratch that's showing up. I don't think the scratches are all that deep. You know, it's 1947. But the dial string's intact, everything moves nicely, off and on switch seems to be working. I did replace the 117 N7. I bought a few of them so I'd have some in stock. The other set, I didn't have the 50B5. 50C5 is the common tube. It's not on this schematic, it's on the other one that you usually see. That took a 50B5 and I didn't have any of those, so I ordered 4 of them. So I'll have them in stock if I need them down the road. Needed one anyway to get that set up and going when the time comes. Excuse me, I'm getting lost here. I'm just so excited at how clean this set is inside. You know, it doesn't look like it's more than a couple of years old, other than the cracking on the cord. And I'm really bummed out about having to replace that original plug. Oh, I can hear it cracking when I move it. Yeah, clunk, crack, crack. It's not flaking off, but it's got to be changed. I'm real sad about that. You can see that this is all factory work here. This is as it came from the factory, other than this ground here for the new filter capacitor. Okay, first thing I'm going to do is we're going to do my normal feed the DC voltage in and see if we can take a chance on powering this thing up to make sure it works. We're not going to power it up though until we know the filter capacitors are viable, at least for testing purposes. Looking over the schematic here, I should have no problem just inserting my B+. Do we have voltages? I even have the SAMs for this one, as well as the riders. I'm looking for voltages. Oh, here we go. This should tell me something. Pin 8 of the 117N7, pin 8 should be 125 volts DC. So we know how much DC I should be injecting into here. So I'm going to flip this up on its back. Actually, let me get the cabinet out of the way and we'll move over to the DC power supply. Oh, I gotta flip the viewfinder over. I'm on the other side of the camera. There we go. Okay. I'm going to turn on the DC supply, let that start warming up. And looking at our schematic here, our B+ would come out of pin 8, and according to the SAMs, this would be 125 volts DC here. It'll go through our cap, our choke, and another cap, and then off to the rest of the radio. But what we're concerned about right now is, can I safely turn this thing on for a short period of time to see if it's going to be functional. And of course we'll go in, we'll cut C25 out before we go anywhere, just so that doesn't explode. You guys aren't going to let me embarrass myself again, are you? Got to remind me to cut that cap out so that we don't have another smoke show. And I will change out C16 up here, the coupling capacitor that couples to the grid of the tube, because this is a brand new 117N7 that I just picked up. It's a new old stock, and I don't want to overdrive that tube and turn it gassy. So we'll change that out. My B plus is turned down, and we'll go minus. Pin 8 runs up to there, so I'll connect right here at the filter cap. So what I've just done is I've connected right at this junction right here, and we're going to inject 125 volts. Can you see the power? Yeah, you can see the power supply over here. Oh, my ground came off. There we go. We'll put this up in the test position, and DC is turned down. I'm going to turn it on, and we'll start bringing the voltage up. And I can see the current needle. I don't know if you can see the current. Probably can't from there. If I get this out of the way, maybe you can. No, not from the angle you're at. Let me move you over here. There we go. As I turn it up, I'm seeing the current climb fall, which tells me the capacitors look pretty healthy in this thing so far. You can see the current meter. Every time I make a move, it jumps up and falls, so they're charging. So this would be about 100 and, if that's 110, 200 and, yeah, right about there. And we'll do a discharge test. You can see how bright that light just got. Those caps are holding a nice charge, and if I go the other way, you can see the current goes up, immediately falls. So those filter caps are totally viable and holding a charge very nicely. So we can safely put power to this without hurting the rectifier, and we have no serious leakage anywhere else, no shorts to ground. So this set, once we've clipped out the across the line cap, and I've changed out that one coupling cap, the grid coupling capacitor, we should be able to put power to this and see if it works. I suspect this set's going to fire right up. Unless it's got a bad tube, I suspect this set's going to turn on and function just fine. Just looking at the condition, it doesn't look like it has that many hours on it. So let me get that cap cut out and the coupling capacitor to the audio changed, so we don't burn up our brand new 117N7, and we'll carry on from there. And as I'm diving into this thing, our across the line capacitor is buried way down here. The lead comes from here, goes underneath all this wiring, underneath this capacitor, and it's the capacitor way down there on the bottom, and then it goes over here to ground on the chassis. We'll just clip the lead off for now and worry about sticking a across the line cap in later. But the reason I'm showing you this is up here on C16, when we come out of the anode of the 1S4, this is a mica cap, I'm not worried about it. We come out through this 002, this goes to the grid, of course, of our either one of our final audio tubes. But we've got a resistor R4 here that branches off and goes to pin 7. And what they did at the factory to save space, because space sure is at a premium down here, I don't know if you can see this wrap of tape around this capacitor. That resistor and the branch that goes off to this tube, they're tied together right at the body of the capacitor. The resistor comes up and ties to the lead of the cap, as does the wire that goes over to the audio section. And they just pulled it up tight against the capacitor and put a turn of tape around it and waxed over it. It's very secure, it's neat, it's clean, and it's obvious that that's a factory, that was done at the factory. It's very nicely done. but they saved themselves a terminal strip that way and saved themselves some room. It's really tight down in there. But something else caught my eye as I was getting ready to go in there. On our audio tube on the 117N7, we have a capacitor C20, a 0.01, and it's coming directly from the anode. This is a negative feedback cap for, it helps with distortion of the audio circuit. Comes out of the anode, comes right down here to the cathode. I'm also going to replace this cap before I put power on this radio, because if that goes short, it's going to take our filament string out, because it's going to come right down here and right through our filament string to ground. So I'm going to change that capacitor and make sure that we don't have a disaster with our string of tubes down here, because our tubes, as you remember, are being powered off of the cathode bias resistor. Whatever this bias drop is, it's going to be around 4 volts. It's going to come down. So we want this cap changed, we want this cap changed, and we want this capacitor cut out. So that's what I'm doing now. Okay, the caps are changed, or the necessary ones are changed, let's put it that way. And we're plugged in. Excuse me. We'll turn this thing on. Start bringing it up. There's 10. Not drawing any current yet. We should at least light up the rectifier, because that's a 117 volt tube. Not seeing any current draw. Oh yeah, the needle's moving just a little bit. Evidently that tube doesn't draw much. In fact, where is the tube manual? Right here. Let's see. You do have a tube manual or two, don't you? 117N7. (117N7). Oh, the heater only draws 90 milliamperes. That meter's not sensitive enough. We're on 1 amp range. Yep. Okay. There's 30 volts. Drawing 60 milliamperes. We are drawing some current. I don't see any heater action, but it's 50 volts. Still drawing about 60 milliamps. (71 volts). Oh yeah, the tube's starting to warm up now. Milliamps. I think we'd have some action. Oh yeah, I hear static. Yeah, there's some buzzing. 50 milliamperes. Huh? All right. Where's my volume controls there? Okay, audio amp is working. Not hearing anything. Do we have any local oscillator? Appear not to have any local oscillator. It's so noisy in here. You're still in frame? Can you see what's going on? There we go. I don't know if any of these tubes are active. We may have an open heater. Then again, we may not. Let me shut this thing off. Shut it all the way down here. And I'm going to check the heaters. Let me get an ohm meter over here. Alright, I would just check over the entire heater string, but we've got some resistors in there which could give us some false readings. So, according to the schematic, let's see if I can get everything in frame here. 1 and 7 should be the heaters. Now, when you're doing this with an ohm meter, make sure your ohm meter is not going to put out any more than 1.5 volts. You can take the tubes out. Okay, that heater is intact. So put that guy back in his socket. One R5, 1 and 7. That's intact. The reason I'm doing this is I didn't hear any local oscillator running, so if all the tube filaments are intact, and you've got to check them with an ohm meter or something like that, because there simply isn't any way to see these when they're on, to see if they're lit. 1T4, yes, 1T4, check 1 and 7. It's not like a regular tube, that one's fine. Yeah, I had it the right way, I just missed it. Oh, I know I missed it with the springs. The little clip pushed the tube sideways on me. Okay, and then we have our detector. One S5. I'm not going to bother checking the, yep, that's fine. I'm not going to, well, I can check it, I guess. I was going to say I'm not going to check the other audio amplifier tube because it's not in circuit at the moment, but while I'm here with the ohm meter, what the heck. Just make sure to cover everything. And 1 and 7 again. Okay, all the tube filaments are intact. Now the next question is, why don't we have any local oscillator? Why those little spring clips make it a bear to get the tube back in? They keep wanting to push it sideways on you. Ah, got it that time. Okay. Let's see if just disturbing them made any difference. No, we still don't have any. 1R5 is our local oscillator. So the local oscillator is not running for some reason. All right. The tuning cap is sticking here a little bit. I'm going to lubricate that, and then we'll get the schematic out and check some voltages. All right. The set's warmed up. The 1R5 oscillator. First of all, let's see if we have any filament voltage. 1 and 7. Make sure that we're getting the voltage drop across our output tube. Alright, we're on a 2.5 volt scale over there, and I've got 1.25 volts. So we've got heater current or filament current. Pin 2 using a 20,000 ohms per volt. Pin 2 should be 87 volts. So pin 1, 2 should be 87. Right on the money. Keep looking at the wrong side here. Pin 3 should be 62 volts. 1, 2, 3. That's about 70 volts, pretty close. Pin 4, 1.8 volts. Okay, that's pin 4. Is that the center? The heck's pin 4? Okay, pin 4 is the grid. And you want that checked with a 20,000 ohms per volt? We'll take a look. Pin 4. 1, 2, 3, 4. I'm on the 2.5 volt scale. Yeah, it's about 0.6 volts. Okay. They wanted 1.8, so that's low. That's real low. But again, I'm finding it hard to believe they want that checked with a 20,000 ohms per volt meter on the grid. And it should be oscillating, so maybe the tube is just gone bad. So I'm going to find another 1R5 and plug it in. I have another 1R5. I just grabbed one out of the box. I suppose I could check it. But the one I pulled out is an EMMERSON. That's probably an original tube. And these 1 volt oscillator tubes can be finicky. Let's see what happens when it warms up this time. And we have to wait for the rectifier to warm up. Normally these tubes, if this tube set was running on batteries, this thing would be almost instant on. These tubes come on like almost instantly. I'm not hearing anything now. Oh yes, I am. All right. We have a local oscillator now. Can you hear it? So we're making progress. Okay. Something's microphonic. Well, once again, the memory card decided to run out on me, just as I was yakking. While the camera was off, I took the opportunity to throw the rest of the tubes in the tube tester since the oscillator was bad. I figured I'd check the rest of the tubes, and a little suspicious here. The 1T4 RF amp on the front end barely moved the needle. Barely came off the needle. The 1R5 oscillator that wasn't oscillating was showing about 20% on the tube tester, and that's why that wasn't oscillating. That's just way too low for one of these battery tubes to oscillate. There's not enough emission there. And the 1T4 IF amplifier was about 5%. So these three tubes were completely, I mean, just unserviceable. If I was a suspicious, oh, I won't go there. We had 3 dead tubes, and the 1S5 was fine, the 3Q4 was fine, and of course the 117N7 is brand spanking new. So I've put new tubes in it, and I've emptied out the memory stick. I'm going to throw these in the trash, sadly. And let's turn this thing on again and see what happens now that there's some working tubes in here. And what takes this thing, I said earlier that these sets normally come on instantly when they're on battery. What we're waiting for is the 117N7 to warm up and the audio amp in there to start conducting. Then the filaments on the rest of the tubes come on, because there it is. Oh, look at that. Let's turn out some of these lights. Oh, let me pull a power supply in the camera here. I'm going to pause it, shut it off. Okay, that's a lot quieter. That power supply, Chinesium power supply, is horrible. And this time I waited for the camera to shut down before I pulled the plug out. So the memory card should be intact. At any rate, well, yeah, I thought the noise was the light. It was the camera.
But the cameras were not on the praying people. The cameras were not on the singers. The camera itself. Whatever you want. Check out the back.
Holy cow.
Still game
This receiver is almost as hot as that car radio, or maybe hotter. Maybe this is better. That's incredible. I knew it was going to be pretty decent with an RF amp in the front end, but wow.
I was just drawing on those shows, but
that happened.
Mrs. and
Okay. Turn that off. That was it. 3 dead tubes. Solved that problem. Not much troubleshooting. That wasn't a very interesting set to troubleshoot. We must be getting on past half an hour at this point. I am going to wrap this up as part 1. I will change out all the capacitors, and when I come back we'll go through and see how bad the alignment is on this set. But just listening to it, holy cow, it probably isn't out all that far, if at all. So that's it for tonight. It's what the heck time is it? Getting on towards 11 p.m. I am going to wrap this up for the evening. Tomorrow I'll come down here and recap it. And when I finish recapping it, we'll pick up from there and do a quick alignment and then move on probably to the GE set. Sorry, wasn't a lot of interesting troubleshooting here. But as you see, we don't need any fancy equipment. Another AM radio to see if the oscillator's running. A voltmeter to check our voltages. And that's all you really need to troubleshoot one of these sets. They're dead simple. They're fun to work on because they're so simple, but it is interesting to see some of the solutions that they came up with back in the day. Like, this is the first time I've seen the tube filaments running on the voltage drop created by the cathode bias resistor. I don't know why more people didn't adopt that. It seems to work beautifully, and it eliminates a whole bunch of heat producing resistors. You look inside of the schematic for most of these AC/DC battery sets, and they either have a curtain burner cord or resistors scattered all throughout it that are just generating tons of heat when the thing is turned on. This doesn't generate any extra heat. It's a beautiful, elegant solution. I don't know why other people didn't do it unless this was patented. And that was not unusual back then. In fact, oh, look, we got a 262. I didn't even notice that. 262 kilohertz IF. I was just going to mention IFs. A lot of times you'll see 465, 456, 457, weird IF numbers that are just off a little bit. And I read somewhere that they did that to get around patent infringement because, you know, 455 kilohertz was patented. How you can patent that, I don't know, but that's what I read at one point, that a lot of these odd IFs were because of that. Okay, that's it. I'm tired. I'm running on. I wish that had been more interesting. I wish there'd been more troubleshooting involved. Maybe I should do the other set just to see what I run into, because that other set's a mess underneath. I'm the radio mechanic. I'm going to call it a night. And next time you see this, it'll be recapped and we can do a quick alignment. Take care. See you soon. Bye.